Hi guys, how's it going? Today we'll be solving this Leetcode media level problem, construct binary tree from InOrder and PostOrder traversal. Let's jump on to the nodes that is given. We've already did the question. So you may assume that the duplicates do not exist in the tree. There's an example given which is InOrder, traversal of the tree, and there's a PostOrder traversal as well. And then we need to return the resulting binary tree, which look like 3 is the root node, 9 is the left node, 20 right. Again, is a parent node, 15 is the left node of 20, and 7 is the right node. But before we jump on to the solution to this problem, right, we need to think how we can actually get to solve this problem in an interview, in an actual interview. I would advise you to pause this video right now, go back and try to solve this yourself. If you still won't able to solve it, come back, look at the solution and see how I solve it for you guys. How I actually landed to the solution was that I tried to use first principles that have been promoted by Elon Musk a lot. First principle reasoning comes around, you have to keep on questioning the why part of the question here or the problem here, that you reach a point where there's nothing left, right? It's getting to the core of the building blocks of the problem. Let's see how that looks like. So first let's question, like, why do we have two traversals given in this question? So that should be the first why of this problem. We have InOrder and we have a PostOrder. So it might look like that we might not be able to do or create a single binary tree from either InOrder or PostOrder. We might need to have both of these traversal in place, but we won't know, right? We still need to question, right? Why do we really need it? So even the question has provided all these, but let's question. And from that, let's start first with InOrder. So in order, let's say we have this traversal, which is the same as the question, but let's assume that there's no post order. How would a tree look like? There is a possibility that 15 could be a root node, and because InOrder is like left, root, and then right, this is the order. So 15 could be a root node where 3 is the left node, 9 left, 7 right, and then 20 as again left. But this isn't same as the one which was the result of in the question, right? So the answer in the question wasn't same like that. Why? Because we don't know the root. We don't know that is 3 the root or is 15 the root, or there could be other possibilities as well for the same tree. And similar situation is for, I would say, the post order. So you now see that the post order traversal that we have here, and we are assuming that we don't have any InOrder traversal. So in that case, how would our tree look like? There's a possibility we can have 3 as a root node and 27, 9, 15, all these nodes. But this is the result. And this is not the right answer to that. But this is not the result nor the right answer to this question. One thing is for sure that we found a root, because it's left, right, and then root. So the root lies in the last part of the array in post order. So 3 is for sure a root. We can start building our solution around that. So how these two merge now? Like you have InOrder traversal, we have post order traversal. So our post order traversal could give us root, while our InOrder traversal could give us, let's say, left and the right subtrees. So now as we have reasoned our problem statement enough, and we have established the reason about we have InOrder and post order traversals together, and we need to use those. Let's look at a solution that could help us get to the answer. So post order traversal, we know that the rightmost element in the traversal would be the root, because it's left, right, and root. Let's take 3 as a root first, and in InOrder, what we'll do is, like, we'll have 3 as the root, and then we'll split the InOrder to left and right subtrees. So it will be like left of everything that occurs left of the 3, which is the root element here. It will be the left subtree, and whatever occurs on the right of the 3, it will be a right subtree. And we're going to call the recursive function on these left and right subtrees to get to the complete tree. One thing to note here is that we'll be building the tree from right first, not the left, because we have post order, right? So you have left, right, and root. The root is 3, and all the nodes on the left of 3 in this situation in post order traversal would be possibly a right node first. And for that preference, we got it, the post order prefers the right node first than the left node. So that's the reason we'll be building from the right. It will be self-explanatory if I'll show you on the code. It'll be easy to understand there. So let's look at the code now. So first I'll be creating a hash map. So a hash map of type integer with the key values as integer, integer is needed to store the index of the root in InOrder, so that we can retrieve it whenever we select the root from post order. I'm sure you guys would remember, as I explained just a couple of minutes back. Let's say we chose the last element from post order, which was 3, and now that 3 we have to look the index. So split up the InOrder traversal array to left and right subtree. We need the index of 3 in InOrder traversal array. For that very reason, we'll be storing that in a hash map. So the hash map, and let's call it a map. New hash map of type. And now we're also going to define the position of the root node in the post order array, and we're going to keep it as, or the instance variable. What we're going to do is we're going to populate the hash map. So because this is going to be from InOrder, so we'll be looping over the InOrder array map.put. Just have that InOrder and you have it right. Now we'll be initializing the root position from the post order array, which will be the last element. In the case you can see it is 3, so that's what we are doing here. And then we're going to have some recursive function which we'll be going to build. We need to have the indices of the like in order INJ kind of a thing, where like left and right, where we would need the left subtree and right subtree. To keep a track of that, we would need the root position and the start to the root position, and then to the root position to the end. So we need at least 2 indexes to maintain that part. For it starts with 0. The last one would be length -1, which will be in order length -1, the total length of the in order array here. Then we'll be sending the post order, and finally we'll be sending the map, right? I think this is all we have right now. We're going to create a function which we like kind of already named above. Build will return a tree node type. We'll have like same in order. So because this is a recursive function, and my previous videos you would have seen that I tend to create the base case first. That helps me build the further solution. So I'm having this base case like if I crosses j as we go into the recursion. So let's just return null. And now what we need to do is like we need to first fetch, because the standard operation that we discussed, where we need to we already know the root. So root post was the index of the root. So what we're going to do is we're going to pick this one from the post order. So this will be the root value, and based on this root value, what we're going to do is we're going to we can fetch the index, right? So let's say here 3 was saved in the map, and it had an index of 1 in this array. So we're going to fetch that, and when we fetch that, we have that root index, right? So we have the root index, which is from map. We can also create the tree node here, which is also the root node. So I'm creating the with the root val, and this root index will be now used basically to divide the in order array. That's what I'm going to do. But before that, I'm also going to decrement the root position and this is done for the post order. Now index points to 20, so skipped 3. Now it has processed 3, right? Points to 20 in post order, so we'll be considering 20 now, because we've already like kind of fetched everything from root position. So we from root position we fetch the root value helped us create the root node. We also got the index of the root element in the in order traversal array. This is the root position. And now what we'll be doing is because we discussed that we need to process the right node first, because we are like decrementing this root positions in the post order, and the post order is usually left, right, and the root. Left, right, root, because root has been used now. So mostly these are the right elements, and because we are moving from the back, so we'll be processing the right. Build again the function in order, then start element, the root index that I just got, but the root index would one index after the root node, so it will be +1, and then the last one would be definitely j, and then a map, and then tree node left equal to again in order, and root index -1. I'm just not referring to the root node now, it's just the previous one node previous to the root node in the in order traversal, and then a map. So in order, so it looks okay now, yeah. And then we'll just hook up all these nodes to the root node. So root dot left is equal to left, and then just return the, yeah. So just the base case, coming back to the problem again, getting the root value from the post order, like which was 3. Then we got the root node created. Then we got the index to the root node from the in order traversal, which is needed to split up the array to left and right subtrees. We called it recursively the right first and then left, because we are picking up and building the tree from the root, right, and then left. So that's the order. That's the reason we are preferring the right node first. And if you don't want to like do this the right first, and you want to be in a traditional left and right first, then you also need to have indexes to be tracked for post order. So in this recursive calls, you should have like some x comma y which need to be manipulated during the recursion for those calls as well. In that case, you can do tree node left first and then right later on, but this one looks good for now, and let's try to run this. It worked. Yeah, now let's submit it. It worked too. Thank you for watching the video, guys. Do like, do comment, and do subscribe to my channel. See you in the next video.